you guys, so today we're going to cover sections 3 and 4, and we will do problem number 10 of chapter 3. And in this section we're talking about current division and voltage division, which are very important concepts in solving simple circuits. So the background you need to solve the problems for sections 3 and 4 is, you know how this is how you derive for current division. So, voltage division. So you start with some black box with an unknown voltage in it. So we have some voltage source, and it's connected to resistors that are in series. It doesn't matter how many there are. I'll do it for a finite amount, and then the mathematics applies to n resistors because the argument doesn't change. So we have, in this case, R1, R2, R3, and R4. So we know that it's connected in series, so there's only going to be one current going through there. So what does that tell us? Well, if we start with KVL, KVL says the sum of the circuit, or the sum of the voltage drops must equal the source voltage. So we have Vs is equal to V1 plus V2 plus V3 plus V4. Well, that's equal to IV1, IR1 plus IR2 plus IR3 plus IR4. We factor out the I, we have R1 plus R2 plus R3 plus R4. And that's just our equivalent. So then I is going to be V source divided by R, V source divided by REQ. Okay? So if I want to find out any of this, let's say I want to find out what is the voltage drop here, what's V3? They're connected in series, so I can say V3 is equal to IR3. Well, we just found I, right? It's V source divided by REQ. So then we substitute for the I, we have V source is equal to REQ times R3. And we can rewrite that as R3 over REQ times V source. So what we just proved here is that for as long as the resistors are connected in series, the voltage drop across that specific resistor will be a ratio of its resistance over the equivalent, the resistance seen by the source, times the voltage source. Okay, that's an important relationship to know. So I'm going to put this here in generic form. So Vj is going to be Rj over Req times Vs, and that's voltage division equation. Now the other important analytical tool that we have is current division. And that's for analyzing circuits that are connected in parallel. So we have some kind of black box, and this time the resistors are connected in parallel. We have R1, R2, R3. So we have I source, some kind of total. It's going to go in here and it's going to split between the three of those. So what if we want to find what is the current through here, like I2? How do we find that? Well, we know V source is going to be I total times R1 in parallel with R2 in parallel with R3. Okay, so now we know what I is. So we know I is V source divided by REQ. So let's see. So then if we want to find the particular, like I, in this case I2, then that should be V source, right? Because they're in parallel, so they have the same voltage drop. So this voltage drop is got to be equal to V source divided by R V source over R2. But actually, over here, I'm gonna rewrite this back in terms of V source. V source is gonna be equal to I times REQ. So we know what V source is. I'm gonna put that substitute I REQ over R2. So what does that tell us? If we rewrite this as a ratio, we have R equivalent divided by R2 times the total by I source. So what this tells us that when you have current connected in parallel, or resistors connected in parallel, and you want to find the current through any branch, pick a branch. The amount of current that will go through that will be a ratio of the equivalent resistance seen by the voltage source. Divide that by the resistance of the branch. So we can write it in a general form as I sub j is going to be a ratio of REQ divided by RJ times the total current. Okay, that is the background that you need to solve problem number 10. So now we can go ahead and work on that problem. So this is problem 3.10. And we are given this circuit here. Ohms are here, 5 ohms, 8 ohms, 12 ohms, and we are asked to find what is the power. We're asked to find the power across here. In order to find the power, we need to find current or division, so we have to find P sub 5 ohms. Okay, so now that means we're going to have to find voltage or current across there and use either P equals VI or P equals V squared over R or P equals I squared R. Those are our choices for how we can come up with but so we need to find the information. So how do we begin this? Well, we begin by looking at the current source. It's going to go here, and some of it's going to go here, and some of it will go here. But how much of it goes here? The way to find out is we have to simplify this into what does the source see. So we have to simplify this into one big resistor in order to know how it will split. So taking from here to here, this is in series, and it's going to be, this is in parallel with these two. So we have 5 is in parallel with 8 plus 12. Oops. Yeah, that's right, 8 plus 12. Well, that's going to be 1 over 5 plus 1 over 8 plus 12 is 20. The inverse of that. So 1 divided by 5 plus 1 divided by 20. This gives me 4 ohms. And as a reality check, 4 is less than 5, 8, and 12, so I feel good that that's probably the right number. So I can replace all of this with 4. 4 and 6 are in series, so I can replace this with 10, right? Because this is going to be what the source sees. So it sees 2 equal resistances on both branches. That means it's going to split evenly. I'm going to have 5 amps going down this direction, and I'm going to have 5 amps going in this direction. Okay, so now let's put back the original circuit. So my circuit looks like this now. 5. And the 2 here are in series, so I'm going to combine them. I had 8 and 12, but I'm just going to combine them into 20. So what happens when my 5 amps gets over here? It's gonna split. Some will go here and some will go here. This is where we use voltage division. I wanna find I sub 5 ohms, right? And voltage division says that I can do that by finding the, taking the I source, the current going into that, right, going into the node, divide that by Req over R sub 5 ohms. That's going to give me 5 amps times, times 5 in parallel with 20 divided by 5. 5 amps, 5 in parallel with 20, we just found that over here, that to be 4 ohms over 5 ohms. So 5 times 4 divided by 5 is 4. So we have 4 amps going through here, and then 1 amp is going through there. Okay, so now we have the current. We can use P sub 5 ohms is equal to I squared, I sub 5 ohms, R 5 ohms, and that gives me 4 amps squared, 5 ohms. 4 squared times 5 is 80 watts. And that's the answer to that problem. Okay, I hope you found that useful.